In all the examples we've seen on substitution and elimination reactions, the substrate has always been an alkyl halide. But there are other groups that can act as leaving groups in the substitution and elimination reactions, and we're just going to look at some of those examples with this video. One common alternative to alkyl halides are alkyl sulfonates, and we've got a couple examples of these compounds down here. You don't have to have these compounds memorized, but if you see these abbreviations, you'll want to know where to go to look them up. And then if we ever need these for exams or quizzes, I'll give you the formulas of these. Due to the fact that these guys are relatively large, oftentimes rather than writing out the whole structure, we'll use these abbreviations in the formulas. Okay, so these alkyl sulfonates make really good leaving groups because they're very stable. Like halides, they are conjugate bases of strong acids. So that means they're very stable, and themselves, they are very weak bases. And what gives them this stability is the fact that they're resonance stabilized. And so we can spread these negative charges out over large regions of the molecule. So we've given the pKa's of some of these different alkyl sulfonides. And if we were asked which one was the best leaving group, well, we're looking for the one that's the most stable, that's the weakest base. So remember, the lower the pKa is, the stronger the acid is. And so the alkyl sulfonides acting as leaving groups are going to be the bases, the conjugate bases of all of these acids. So this is the strongest acid, and so its base is going to be the most stable and the weakest base, so this one would be the best leaving group. And the reason this is such a good leaving group, not only is it resonance stabilized, but we also have these fluorines that are going to contribute to the stabilization of the negative charge by inductive effects. So in what ways are these alkyl sulfonates different from the alkyl halides? Basically, they're not different. All of the things that we've learned about the substitution and elimination reactions, the same things hold true for these alkyl sulfonates. Another class of compounds that can be involved in substitution and elimination reactions are alcohols. That being said, OH minus is a terrible leaving group, right? OH minus is a strong base, so it doesn't make a good leaving group. So in order to get these substitution and elimination reactions, we need strongly acidic conditions. So if we react our alcohol with hydrobromic acid, if we first protonate the alcohol, while OH minus is a terrible leaving group, water is a very good leaving group. And so we can have these substitution and elimination reactions with alcohols when we have strongly acidic conditions. And so we first have to protonate the alcohol before the water can then act as a good leaving group. So the mechanism for substitution reactions of alcohols can either be SN1 or SN2. Primary alcohols react via SN2, but secondary and tertiary alcohols react via SN1. Strong acidic conditions are protoconditions, and normally this would favor SN1, but since primary carbocations are too unstable to form, primary alcohols react via SN2, and then because we have the protic conditions, if we have a secondary or tertiary alcohol, it's going to react via SN1. We can also have elimination reactions with alcohols, and again, the strongly acidic conditions are very protic, and so that's going to favor E1 for secondary and tertiary substrates.